So here we go to answer today's warm-up questions. 4 problems today. Should be ready to grade your work. For 1 and 2, they're asking us to put it in logarithmic form. So the first thing that tells us is that we're going to need the word log. We then look for the base, which will be the 5. We always put the answer here, 25, and then it's equal to its exponent. So log base 5 of 25 equals 2. Number 2, again, need the word log. The base this time is 3. The answer is 243, and it's equal to the exponent of 5. Going over to 3 and 4 where your directions changed. We're evaluating them now. When we evaluate, the first step is to set it equal to x. And then we go base to the x exponent is equal to 8. So what number or how many times do I multiply 2 by itself to get to 8? And that's going to be 3 times. 2 times 2 times 2. Number 4, same setup. So we need to set it equal to x. This time there isn't a base down here, so we know that it's that invisible 10. So 10 to the x equals 10, because there's a 10 here for the answer part. So 10 to what power is 10? That's going to be to the first power, so x equals 1. Here are your 6 problems that were on this page of notes. Number 1, to get the 12, you multiplied the 4 and the 3, because you want to write it as 1 logarithm instead of 2. Number 2, you divide since it's subtraction. Number 3, we had multiple parts here. The addition means we have to multiply the 4 and the 2. Subtraction means we divide by the 8. So 4 times 2 is 8. 8 divided by 2 is 1. Numbers 4, 5, 6, we're doing the opposite. We're expanding them. So however many pieces are in there is how many logs we need. So since we have an x, y, and z, that means 3 logs, 1 for each of them. They're being multiplied, so we expand them by addition. And there's no exponents or anything, so this is the answer. Number 5, we have an x that's being divided by 2 parts. So the 2 parts need to go in parentheses. Since the 2 parts are being multiplied, there's an addition sign. And then since x is being divided by both parts, it's a minus sign. Number 6, we have 3 parts here. Now here's where you could possibly have gotten confused. This 6 is being multiplied, so we have to change it to an addition. Don't try to pull this 6 to the front of it. Only exponents go to the front of a log. So we have log 6 plus 3 log x, which is that x cubed, and then plus log of y. Using that same page of notes, we're going to be finishing them up today. And make sure you have your scientific calculator out ready to use. Today we're going to use the change of base formula to evaluate logs when we're not able to do that mentally. The change of base allows us to change them into a base of 10. And the reason that we're going to use 10 it's the most convenient because that's what your calculator uses. Okay, you could use any common base, but then you'd have to do the work yourself where we already have it programmed into the calculator this way. If you look on your calculator, you should see a button that says log, and that's the button you're going to be using today. So take a second to find that button on your calculator, help anyone that might need it. All right, hopefully you've all found it. To evaluate, we're simply going to divide the logs using your calculator once we've applied the change of base. So we're going to be taking the log of the number and dividing it by the log of the base. Okay, base always goes on the bottom. So if we look at the first example here, it's going to be log of 21. And again, it's base 10, but 10 is the invisible one, so we don't need to write it, divided by log 81. So in your calculator, remember it could work one of two ways. You might put in the log button and then hit 21, or you might have to hit 21 and then the log button. To know which way to do it, log of 21 is approximately 1.3 and then 3/2. Now, obviously there's more to it, but that's an approximation. So once you get that in your calculator, you know you're doing this correctly. And then the same thing, log of 81 is 1.908, and then more digits. So then we're going to divide these two numbers. And you should have 0.69, and we're going to round it to the next digit. So we have 6929. We're going to round it to the 2, which is in the thousandth spot. The 9 behind it tells us to round up. So this is approximately 0.693. Now you can actually do this in your calculator without having to write down these numbers in between. So again, some of you might do 21 log and then hit your divide button, and then 81 log, and if that gives you 0.693, then that's how your calculator works. A lot of you will simply be able to do log and then 21 divided by log 81. And again, you'll know if you got it right by getting 0.693. So take a moment, make sure you got that, and then if you didn't, check with the neighbor to have them help you type it into your calculator if they figured it out. All right, hopefully you have all figured out your calculators. So let's try one more example together. So our next example, going straight down, we use the change of base here because I don't know what exponent 8 would be to get to 32. I don't know how many times I'd have to multiply 8. I know it'd be a decimal, and that wouldn't be really easy. So we have log 32 divided by log of 8. So again, you can type this straight into your calculator. You don't need to do any in-between steps. And you should get 1.6 repeating, or if you have a calculator that gives you fractions, 5/3, or maybe you rounded it to 1.67. All three of those would be acceptable answers for this problem. And generally, your directions will tell you which decimal place to round to. Now go ahead and try the two U-tries over to the right. When you get them, check with the neighbor to see if you got them, if you matched answers. If not, discuss it, and then unpause this when you're all ready to check your answers. All right, for the first U-try, you should have written log 36 divided by log 5. And again, it makes sense to do it this way, because if we were to solve this using our other way, it would be 5 to what exponent equals 36. Well, I know that 5 times 5 is 25, and 5 times 5 times 5 is 125, so I'd be looking for a decimal for the exponent of 5, and that would be challenging. So this is a way to get around it when we don't have an exact exponent to work with. And you should have gotten an answer approximately of 2.227. Again, if not, have someone help you figure out how to type this into your calculator. The next you try should have been log 18 divided by log of 4, and you should have gotten approximately 2.085. And again, the two ways to type this into your calculator are either to do the number first, then the log button, divided by 4, and then the log button again, or type the log button first, then the number, divide by the log button and the number again. There are 3 more problems that I want you to practice. Notice here they actually give you directions of where to round to, the thousandths, so make sure you round appropriately because that is part of your final answer. And then we'll check these, and then you'll have some time in class to get started on your homework because it's a longer assignment tonight. So unpause this video when you are all ready to check your answers for these 3 questions. For number 7, you should have it set up as log of 32 dividing it by log of 4, and that actually should have simply come out to 2.5. If some of your calculators gave you 5/2, that is also an acceptable answer. Number 8, you should have set it up as log 5 divided by log 3. This one you did have to round, and it should have rounded to 1.465. And the last one should have been log 15 divided by log 2. Again, you should have rounded and gotten 3.907. If you missed any of these, check with someone that did get them correct and have them explain what they did in order to get their answers.